Hello everyone, welcome back to my channel. Today we will be diving deep into the numerical integration methods, that is 1/3 Simpson rule, and step by step Python as well as Numpy based implementation. Let's get started with Simpson's 1/3 rule. First we want to recap the previous method, that is trapezoidal method, as was discussed in the previous video. And in order to integrate a function numerically, say from a to b, and it's a one-dimensional integration, first we consider it graphically, and this white line curve is a function fx, and we just approximate a small segment of this limit, say a to a plus h, that is via a straight line. This is yellow color straight line between these two points, and which is not actually the curve, it's a straight line fitting between these 2 points a and a plus h. And in order to approximate the area under this curve, we use this trapezium. And what is the area of this curve? We know that is half into h. H is the distance between these two parallel sides, and the height of these two length of these two sides, that is here the length of this curve, length of this piece of straight line is fa, and this piece of straight line is fa plus h. That is very simple. The area under the trapezoid is half h into fa plus h. And if we extend this for multi-segment things, and we will get that rule as was discussed in the previous video, and you can check it out. And but in Simpson's rule, each subinterval, that means this interval, this subinterval of integration is fitted with some parabolic function to approximate the curve over every pair of adjacent intervals. Here we consider a pair of interval because it's a parabola. Parabola means this sort of equation, ax square plus bx plus c, because here 3 parameters are there, a, b, c, and we use this sort of thing. We consider in this, you just look into this graph. Say this curve is our function fx, which we want to integrate numerically, and now we approximate or fit or interpolating polynomial, that means a polynomial which passes through these 3 points a, b and c, yellow line curve, which is a parabola or second degree polynomial. The equation of the parabola is something like that, ax square plus bx plus c. Here we fit a curve something like that, and we just say this point is x0, and this point is x1, and this point is x2, and our first aim, and these heights, these distances are say h, and this distance is h, and therefore we want to integrate from x0 to x0 plus 2h in order to approximate the area under this curve, by this parabola, yellow line one, this yellow curve, and this is an approximate. The actual one is this one, but I am just integrating the area under this yellow curved, under this yellow curve, and that is basically x0 to x0 plus 2h, ax square plus bx plus c dx. And parabola is a second degree polynomial, but unlike in trapezoidal method where we have used straight line. Now we want to find out the area under this yellow line, and for the sake of simplicity, we transform these coordinates, say shifting the origin. I shift the origin at the midpoint, that is 0, and the left side of the midpoint is minus h distance apart, and the right side is plus distance. Without any loss of generality, we can shift the origin at x1, and therefore we can easily calculate the area under this parabola. So what is the area? That is, I am calling it delta s1, and that is I have to integrate from minus h to plus h, because we have shifted the origin to x1, which is 0, new designation, and we have to integrate x square plus bx plus c dx, which is as simple as that, ax cubed by 3 bx square by 2 plus cx, and from my h to h. After doing this simple algebra, and if you pause the video and you can check it out, and it will be delta s1 2a h cubed by 3 plus 2ch. This is my 0th equation. Now we use the boundary conditions. Here boundaries are, say my equation is y equals to x square plus bx plus c. At point minus h, that is left side of the curve, which is y naught, I am calling this y naught, say that is a x, value of x is h, minus h, a h square minus bh plus c. At the midpoint, at the midpoint x is 0, so that's why the y1 equals to c at 0, and this is my equation 2 and this is my equation 1, and y2 is a h square plus bh plus c at the right point of the origin, at point h. Now we just from equation 1 we will get y naught equals to h square minus bh, and c is y1. I am putting the y1 here, and as well as in the equation 3 y2 equals to h square plus bh plus y1. And now after transposing and sanitize all these things, and y naught minus y1 h square minus bh, and y2 minus y1, that is h square plus bh, and adding these two, it turns out to be y naught, this y naught here and y2 here, and minus y1 is twice of minus 2 y1, and in this side these two are cancels out, these two are cancels out, so 2a h square, as simple as that. And from equation 0 we can say delta s1 is 2a h cube by 3 2ch, and after putting 2h square here, 2h square here, and we will get h by 3 y naught plus y2 minus 2 y1, and here is 2 y h into y1, as simple as that. And after just simple transposing, we will get area of the first two strip, pair of strip, that is delta s1. Delta s1 is equals to h by 3 y naught plus 4 y1 plus y2. Similarly, area of the next two strip, if we consider imaginary, in imagination, that is h by 3, and the left side y2, and middle point 4y 3. This is your, sorry, this is the middle point, and this is and you just look at this, this is the middle point y1, y naught is the left side and y2 is the right side. Here just correct it, and this is your left side, and this is you just look at this, y1 is the midpoint, y1 is the midpoint, and y2 is the right side of the graph, y2 is the right side of the graph. That means in the similarly y2 is the left side of the next two strips, and middle point is 4y3 and y4. In this way we can continue. And for multi-segment Simpson's rule, we have, because you think of something like that, and it's a multi-segment thing, and this is your x naught and to xn, that is equals to b, and this is equals to a, and you are just, and these two pair and next two pair, and in this way you are going, and these two, the area of these two pair, this pair rather, which is this one, and next to pair is this one. In this way, if we just think about this, say this is x1, I am extending, this is x2, this is another pair, and you have to we have, in order to integrate from a to b, we have to divide the segments pair in such a way we have n by 2 number of pairs, and n must be even always. It is obvious because it must have, n must be even, and this is the pair, and this is one pair, this another pair, and in this way we always think of this pair, and we know the area of this pair. We cannot integrate up to this point, one pair will be left out and there will be error. So therefore, in order to get a multi-segment from say a to b, the whole integration from range a to b, will pair it up, this is your fx and this is your x, and just I equals to 1 to n by 2 pairs, say h by 3 is coming out, y naught plus 4 y1 plus y2, and the second pair area is this, and the last pair is y n minus 1, n minus 2 plus 4y n minus 1 plus yn. And if we just simplify it, y0 is here, and all the y2 is here twice, and y4 is also twice, and in this way, because this is the left, this is the, and if you just, this is your right side and this is the left side of this pair, of this pair, and therefore it will come twice. So all the even number terms are twice of that, and here the midpoints are 4 times, and 4, that means odd points, 4 into y1 plus y3 plus y5 dot 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 yn minus 1. N is even, so that's why n minus 1 is odd, and the last term is yn is only 1 times. Therefore we can easily generalize it something like that: h by 3 y0 plus yn plus 2. J is running from some index, j is running for 2, 4, 6, n minus 2. Here y2 is basically we can say y equals to ax square plus bx plus c, which is you can call this as fx. This is your fx, so some fxj, and j is basically 2, 4, 6 up to n minus 2, and 4 times 1, 3, 5 up to n minus 1, that is xj. xj is j can take only odd values. And if we do this numerically, how to do that, because we will do this via Python and is much more advanced Numpy implementation, we will see. And first you have to add these two terms, and after this you have to adding the even terms and odd terms. Now we are going to discuss the Python implementation. From theory we know the formula: h by 3 y0 plus twice into y2 plus y4 even terms, and 4 into y1 plus y3 plus y5 and odd terms, and the last term yn. We do not need any Numpy, so I am just removing this. First we use pure Python. First we define a function. In this case, first we take a linear function x. If we integrate x, that means say limit 0 to 1, then whatever may be the limit, we integrate the function. This is your integrand. This is your integrand. It will return x. Say, now I define another function which will take care of the Simpson's method, and it will take the argument a, argument b, it is one of the limit and another limit, and number of intervals. First we calculate h. H is very simple thing, which is b minus a by n, and after that we create a list, say x underscore I, which is the points. That means if you just think of the graph, first point is say a, where a plus I star h, that means I into h. The first point is a, and then the next point is a plus h, another point, next point is a plus 2h, and in this way up to n plus 1, because here n is even number, but number of points will be odd in order to get a pair. I hope you understand, because it is running from 0 to n, that means n plus 1 points. So just we create a list of points x underscore I was equally spaced a plus ih for I in range 0 to n minus 1. It will create a list containing equally spaced points. Now we calculate the first, say, function I of another list I, another list which calculates these functions. fxi, it will calculate the function fx for xi in x underscore I. Here xi will coming from this list. You just take the printout of this list and you will understand what is happening here. Just run it. and check it. And this is your xi, this is your x underscore I, the first list x underscore I, and second one is the function computation. Here the xi's are 1, 1.1, 1.2, 1.3, and in this way going up to say 2, because I am calling this function with 1 to 2, say in this case the a and b is 1 and 2, just considering. If we make it 0 to 1, and you will, I am making it for simplicity say 0 to 1, I am run it, and 10 points, I am calling this, the value of n is 10, so therefore this is the value. And here function is so simple, so that's why the I is also identical. And if we make it x square, you will understand it will be squared up. This will be squared up, and you can see the last point is 1 and 0.9 is 0.81, and you see this I is basically the integrand, computation of the integrand at these points, at x underscore I points. I hope you understand this two line. Now I calculate the first two terms and initialize this variable int, the value of the integration, with the first two terms y0 and yn, and I0, that means here the integrand is I0, and I minus 1, that means the last value, that means yn. I am just initialize the int variable by this, the first value and last value, summing these two values and putting into the int. Now I run a for loop from 1 to n with gapping 1. If I is %2, that means it checks whether it is even. If it is divisible by 2, that means equals to 0, that means it's an even number, and just you check the even number term will be twice, and just adding the int with twice of I in the third bracket I, that means I will be accessed from this list, and that will be added to int. Otherwise, that means else part, the odd terms will be there, that means 4 times of the odd terms, all the odd term will be added here. And after this loop, all the odd terms and even terms will be added, as well as the first term and last term, and you just multiplied overall by h over 3 because it is a weighted sum, and h over 3 will get the value of the integration and return int. Now if I call the simp13 abn, say 0, the one of the limit, another limit is 1, and 10 points, it must be even, and it will, the number of points will be 1 more, but number of division will be 10, it's even. So now we just call this integration is 0.5 because it's x square by 2, 0 to 1, that means 0.5. I hope you understand. If you you can increase the number of points also, and all that, and many more things you can do, and it is very much useful in science and engineering. But it's many more lines, and it is an elaborate implementation. But now I discuss the Numpy implementation. First of all, you have to import Numpy as NP. NP is a local name you can think of. Similarly, the function say fx is say x, very simple function. Now I use the linspace function from the Numpy. In order to call the linspace function, say x and h, and two terms are there, two variables are there, np.linspace, say 1 to 2, say I am calling same thing I am doing 1 to 2, 0 to 1. Now I am just creating 11 points because the number of points must be 1 more, because it is starting from 0 to n, that means n plus 1. Say it must be odd. In this way you have to implement in this Numpy implementation 11 points you need. So therefore, and ret step true, that means what is the spacing between the x array points will be returned. Just you look at print x, that is 0, 0.1, 0.2, 0.3, 0.4, 0.5 in this way up to 1. And here how many points are there, you can check it by length of x, you can check there are 11 points, there are 11 points, as well as you can print the h. H means the difference between two points, and you can also print x. Here length of x is 11 and h is 0.1 and x array is something like that in a one line implementation. And now you calculate the you are just creating some array containing the functions at these x values. Say fx equals to one line. This line calculates the function values at each x array points, this array, and by applying the function fx. Say this is your definition of the function, linear function, that is I underscore g, that is equals to fx, means at every x points this function will be calculated. Just you look at it, print I underscore g, the same function, because x, this is x and fx are identical. If you make it square, and you can check it out, and 0 is 0, 0.1 is 0.0, and square it up, 0.2 is 0.04 and 1 is 1. So you can understand what is the meaning of this line. Now I am just blocking this part. Now it is a one line integration without any loop. First I just calculate the this is the first value of the array, and if you just calculate the first value, just you make this is the first value. I hope you understand. First term that will, and it is making it x in order to simplify it. This is the first value, and if you print only x, just check it out, rather this one, just look at it, the first value of the integrand, this is the first value, that means 0, and in order to calculate the last value, I just calling it by -1. This is 0.5, and this term will fetch the last value, and this term will fetch the first value. Now just summing this without looping is 4 times only the even terms. How to calculate the even terms? And from even terms, 4 times of odd terms, y1, y3 and y4. How to calculate the odd terms? Say I am starting from 1, and it is length of x, that is there is a total length of the array, and 2 in the gap of 2. Just you see this, and this will bring the loop, this will generate the loop, generate a list, that is 0.1 and once that is 0.3 2 step, and 0.5 only the odd terms. I hope you understand. One, 3, 5, 1, 3, 5, 7, 9. I hope you understand. And in order to just fetch the even term, just you start from 2, and in the gap of 2 and 1 length -1, just you check it out, 0.2, 0.4, 0.6 and 0.8, because -1 it will, otherwise if you do that, you just check it out, that will include the last term, but we do not need the last term, because otherwise it will be 2 times will be added. So that's why I am making it -1. This will be only the even terms excluding the last term, 0.2, 0.4, 0.6 and 0.8. I hope you understand. Therefore, if we just add np.sum, a function, np.sum function, and within that ig underscore 1 to length of this array in the gap of 2, that will be a odd index terms, and twice of np dot sum I underscore g is starting from 2 to length minus 1 in the gap of 2, that will generate the even term, and sum, you take the sum due to np dot sum function. It is a one liner code for Simpson's 1/3 rule. Very easy and very fast, and if you understand this slicing technique, you can use the technique. It is a very fast implementation. It is very much used in engineering, science and all this. I hope you understand. If you have any query, you can post your question in the comment box, and if you have any query, you can mail me and anything. Please like, subscribe and share. Thank you for watching.